Assalamu alaikum everyone. I'm sure you are able to see the Excel sheet. Today I'm going to cover the topic finding PMT for annuity. We have already covered multiple different types of annuities, and currently my interest is if I know the present or the future value, can I find the PMT? So let's start with a very simple question. We are given the PV of an ordinary annuity and we have to find the PMT. A company wants to accumulate funds to repay a loan of 50,000 today. The loan carries an interest rate of 8% per year and the company will repay it through equal annual payments of for 6 years. Calculate the annual payment PMT assuming the payments are made payments form an ordinary annuity. So if we know we have 50,000 today, that means it is our PV at an interest rate of 8%. R is 8% and equal payments are made for 6 years. That means T is 6. Inserting PV of 50,000, R of 8%, and T of 6 in ordinary annuity formula, we can find PMT. 50,000 divided by the annuity factor. What we find is that PMT is 10,815. If we invest 10,815 for the next 6 years at 8%, currently the present value of that payment, of all those payments, will be equal to 50,000. Moving on to question number 2. It's PV is given and we have annuity due. A business purchases equipment worth 40,000 today. Again, 40,000 today is the present value. The supplier allows payment through equal annual installments for the next 5 years at an interest rate of 9%. Payments must be made at the beginning of each year. Beginning of each year means we have an annuity due over here. So using the PV of an annuity due, look, this is the part which indicates it's an annuity due, the 1 plus R at the end. So putting all the values, 40,000 PV, 9% interest rate, 5 years in T, we will find a PMT of 9434. As I told you earlier, it's best if you do it once in your calculators. Put 40,000 divided by, start a big bracket and put all the rest of the values once in your calculator. You will get precise answers. Moving on to question number 3. Now I'm increasing the difficulty of the question. We have the present value of cash flows. We also have the terminal cash flow. And we have to find the PMT. An investment requires 60,000 today. So the present value of the cash flow stream is 60,000. And it's expected to generate an equal annual cash inflow for 5 years. There's also a terminal cash flow of 10,000. So if you invest 60,000 today, it will give you equal payments for 5 years. And at the end of 5 years, it will also give you 10,000. So you're getting two things, an annuity as well as a terminal cash flow. The required rate of return is 10%. Now, when you have a terminal cash flow, the first thing you have to do is find the present value of the terminal cash flow. Since it is only one payment, FV of 10,000 divided by 1 plus R of 10% and for 5 years, we can find the present value of this cash flow of 6,209. Now, the total PV of this cash flow stream is made up of two things, a PV of an annuity and a PV of a terminal cash flow. PV of annuity is then the total payments, the PV of the total payments, which is 60,000, minus the PV of the terminal cash flow. What is left is the PV of annuity. So 60,000 minus 6,209. We get 53,791 as the present value of annuity. Once we know the present value of annuity, we can easily find PMT. We know the PV of the annuity. We know the rate of return, which is 10%. We know it's for 5 years. Put T is equal to 5 and R is equal to 10% in this question and find the value of PMT. So if we invest 60,000 today at an interest rate of 10% for 5 years, this cash flow stream will generate first 14,189 for 5 years, equal payments, plus another 10,000 at the end of 5 years. Any question which has terminal cash flow, you have to work with the terminal cash flow individually and subtract it from the present value before you start working on the annuity. Anyone who has any issue with this question? Okay, moving on. So this question is a future value question, but the complexity has been increased because now we are not only talking about future value, we are also talking about monthly payments. A firm wants to accumulate 80,000 in 7 years. Any cash flow you generate in 7 years is a future value. So T of 7 years that earns 7% annual interest rate compounded monthly. The annual interest rate is 7%. Now we know for monthly compounding, M is 12. 7% per year indicates that the monthly interest rate is 7% divided by 12 or 0.58%. And the number of months is 7 into 12 is 84 months. Adjusting the future value formula for I and N, now simply put I of 0.58% over here, N of 84 and FV of 80,000. You will get an PMT of 740. If you invest 740 monthly for 84 months at a monthly interest rate of 0.58% compounded monthly, you will get 80,000 at the end of the period. Now let's make it even more tougher. What if it was a growing annuity? And growing annuity, and then I also made it an annuity due. So that adds another element. An investment opportunity requires an initial investment of 120,000 today. Initial investment of 120,000, that's the present value. The investment is expected to generate quarterly cash inflows for the next 10 years. 10 years, quarterly cash inflows, that means M is 4. With the first payment received immediately today, that's annuity due. The cash inflows are expected to grow at a rate of 1.5% per quarter. You are given the quarterly growth rate. That means you're already given the GN, not the G, the quarterly growth rate. In addition to the quarterly cash flow, the project will generate a terminal cash flow of 25,000. So we also know a terminal cash flow at the end of 10 years. This is an epic question because it has other compounding frequencies, it is growing annuity, it has terminal cash flows. So if you understand all the individual elements of this question, and if you look the number of things I've highlighted over here, every single part of the question is important. It is telling you what type of formula to use, what you have to do. Annuity or ordinary annuity, what is the present value, terminal value, etc. Now, the interest rate is 10% per year compounded quarterly. So since it's an annual interest rate, 10%, now first find the quarterly interest rate. That's 10% divided by 4, 2.5%. A number of quarters, which is 10 into 4, 40 quarters. Now we are required to find the amount of the first quarterly cash inflow, PMT. But before we talk about the annuity part, we have to subtract the terminal present value of terminal cash flow from the total present value. Using the same formula, PV is equal to FE over 1 plus RI power N. Since the compounding is happening on the quarterly basis, we have to use I and N, 2.5% interest rate for 40 years, 40 quarters, not R and T. We cannot use R and T when compounding is any other frequency. So FV, even the 25,000 terminal cash flow has to be discounted at 2.5% quarterly interest rate and for 40 quarters. So the PV of the terminal cash flow is 9311. We know the total PV of the cash flow stream is 120,000, of which 9,311 comes from the terminal cash flow. This means the present value of the growing annuity due is 120,000 minus 9,311 or 110,689. Now, using the present value of an growing annuity formula, look, this 1 plus I over here indicates its annuity due. Put the values of GN 1.5%, I of 2.5%, N of 40. Over here, it will be 1 plus I. It's only compounded for 1 quarter. And we can find the PMT of 3328. As I've repeatedly said in class, once you know your formula, once you have the values, once you have input the things, do it on the calculator. Don't do it step by step. Your answers are going to go haywire. Put everything in your calculator, do one calculation, and you'll be done. Any questions over here? Anyone who has an issue? Okay. Then I have another question. We are given an irregular cash flow stream, and then we have asked about, rather than the irregular cash flow stream, is there an equal annual payment plan that will make my cash flows equal? An investment project is expected to generate the following cash inflows. 15,000 at the end of year 2, 18,000 at the end of year 4, 25,000 at the end of year 6, and 30,000 at the end of year 8. At an interest rate of 9%, when we have an irregular cash flow stream, we can divide them into separate cash flow streams and then find the present value of each of them individually. So 15,000 divided by 1 plus 9% power 2 will give me the present value of the cash flow stream, and the present value will always be at period 0, not period 2. Same for 18,000 divided by 1 plus 9% power 4. And repeat this for the rest, we would get the present value of the individual cash flow streams. If we have the present value of individual cash flows and we want to find the present value of an entire cash flow stream, so the present value of this entire cash flow, add these individual cash flows, present values. So take the sum of these, and that's 55,339. Now, the present value of the irregular cash flow stream is 55,339. The question says further on, instead of receiving these irregular cash flow streams, an investor prefers equal annual payments for 8 years with payments made at the end of the year. So for 8 years, for the same interest rate, we want an annuity. Now, if the two cash flow streams are same, their present value should be same. The present value of the irregular cash flow stream and the present value of the annuity should be same. So whatever irregular cash flow stream present value found, I'll plug it in as the present value of annuity. We know the present value of annuity, we know R and T, we can find the PMT. Done. This question is as easy as that. All you have to do is understand the question, understand what it's requiring. The first part is separate. It's talking about an irregular cash flow stream. Find the present value of the irregular cash flow stream. In the second part, it's asking you what annual annuity will convert this irregular stream into an annuity. So rather than having 15,000, 18,000, 25,000, and 30,000 payments, 8 years, if you give me 9,998 rupees every year, the two cash flow streams will have the same amount of money. And now we only have one more question to do. With that, uh, this PMT thing is done. You can do Using this logic that I'm trying to explain over here, you do as many questions as you want. In this question, we have a multi-stage TVM problem. So we will invest first and then withdraw. And the target is same, find the PMT. A person plans for retirement by first saving for several years and then withdrawing funds for living expenses afterwards. For the first 12 years, the person deposits equal annual amounts into an investment account earning 8% per year, compounded annually. Deposits are made at the end of each year. After the 12th year, the person stops depositing and begins withdrawing equal annual amounts for the next 15 years, with the withdrawals made at the end of each year. The account continues to earn 7% per year during the withdrawal period. Now, this person is working on two separate timelines. For the first 12 years, he is investing equal annual payments. He's investing. Every year he makes a deposit. And then for the next 15 years, he withdraws money. Uh, we know how much he withdraws as it's stated in the question. The person wants to withdraw 25,000 per year during the retirement phase. So in the first part, he's investing equal amounts every year. And in the second part, he's withdrawing. Now, how much money can this person withdraw? Depends on how much money his original investments have grown to. So, in the first timeline, at the end of year 12, the future value of his investing is the amount of money he has that he can use. If a person invests for multiple years and then wants to take out money from that, all the money he can take out is only equal to the money that he has at the end of that period. So for 12 years, he's investing the future value of the entire cash flow stream at the end of year 12. It should be equal to the present value of all the withdrawals. But notice for this 15-year timeline, the second timeline of 15 years, year 12 is actually year 0. Because once 12 years are gone and he starts withdrawing, that's another timeline starting. And that period is 0. So in this question, we have to do two things. First, we have to find the present value of all the withdrawals. And since those present value of all the withdrawals should be equal to the future value of all the investments, we can find out how much did he invest. And that's the precise question. First, determine the amount required in the account at the end of 12 years to support the withdrawals, and then determine the annual deposit, PMT, that must be invested each year for the first 12 years. So at the withdrawal stage, we know He wants 25,000 per year for 15 years at an interest rate of 7%. So we can find the PV as 227,697. If he's investing if he's withdrawing 25,000 for 15 years, at the end of or at the start of the withdrawal stage, he should have 227. That 227 came from the investing stage. So putting this PV and FV together, at the investing stage, the FV should be equal to 227. And the investing stage is for 12 years at an interest rate of 8%. So using the FV formula, sorry, this is the incorrect formula. I should put the FV formula over here. Give me a second. So using this FV formula, FV is equal to PMT into 1 plus R power T minus 1 over R of 8% and T of 12. We find the PMT to be 11,999. If you invest this amount of money every year for 12 years, you can withdraw 25,000 for 15 years. And in this type of questions, you have to understand the logic, understand what is happening, how many timelines are there. In multiple books, you'll find such investments problems. You can see problems like a person investing today, then taking them out in the future. You might have to find the PV today, any of these type of problems. Someone is giving you a birthday present today, you invest it, grow it for some years, and then start taking out money. Any of such scenarios, you have to think about the timeline as two separate parts, the ending of one timeline and the starting of the another timeline. That has to be the common point. So FV of one timeline, PV of another timeline will have to be set equal. And only then can you solve such problems. Now, if any of you have any issues, let me know. Uh, Otherwise, this is it for today.